Welcome back to Computer Programming Laboratory, subject code 18, CPL 27. Okay. Today we will discuss program number 14 as per your syllabus. That is, develop a program using pointers to compute the sum, mean and standard deviation of all elements stored in an array of n real numbers. Means you have to write a program using pointers. I hope you know the concept of pointer. Pointer is a variable, v stores address of another variable. Right? Pointer is also a variable, v stores address of another variable. That concept we have to use. Then you have to compute sum, mean and standard deviation of all elements stored in an array of n real numbers. Right? I know how to calculate sum of n numbers. I hope you may be knowing how to calculate sum of n numbers, how to calculate the mean of those numbers, then how to calculate the standard deviation you may be knowing. But just I will recall that. Right? Sum means addition of all numbers. Right? Addition of all numbers again here means when it comes many numbers, it will go array. Again in this case single dimension array will go. Right? Sum is nothing but addition of all numbers. Then mean is nothing but addition of all numbers divided by total numbers. Right? Addition of all numbers divided by total numbers, that is mean. Then what is standard deviation? Standard deviation already I have displayed on this screen. Standard deviation formula is square root of 1 by n summation of I 1 to n bracket xi minus mu bracket square minus mu bracket square. To calculate what is mu here, mu is what is mu? Mu is mean. In this case mu is mean. Right? Then what is xi? Xi are elements. Xi are elements. First element minus mu bracket square. Second element minus mu bracket square. Then addition of all those. Then add all those. Add all those. Then divide it by n. Then divide it by n. Then square root is standard deviation. Right? We have to write program for this formula now. We have to write program for this formula. Means you have to calculate the mean. Mean is nothing but mu. Right? Then you have number of elements. Then you know how to calculate the sum. Sum is total number of elements. Then mean is total number of elements. By is all elements by total number of elements. Then this is the standard deviation. Means you require mean, then element. This formula we have to write program for this formula. For same formula we have written program. Right? That is how we have to write program. Right? Directly we will go to program. That is this program. Right? That is this program. Develop a program using pointers to compute the sum, mean and standard deviation of all elements stored in an array of real numbers. Right? Hash include stdio.h, hash include math.h, then hash define max size 10. This is a preprocessor directive. There is a macro. We are defining maximum size 10. Means now onwards wherever you use max size in your program, that max size will be replaced with 10. This is the one preprocessor directive. I hope you have studied, or you may be going to study this. Right? This is a preprocessor directive. This is macro definition. Right? Then void main, float x max size. Now I am using max size here. Whenever my compiler starts executing this one, this will be replaced with 10. This will be replaced with 10. Means array I have declared x max 10. This is the pointer variable. How to declare a pointer variable? This. Again, as I told, pointer is also variable. He stores address of another variable. It has a capacity of storing address of other variable. But these are also variable. Only these variable will store the values. These variable will store the values. But this variable will store the address of other variable like this. Means if you want address of this variable, we can store it in P. But this variable has value. But P has address of another variable, which variable you have stored. Like that, that is the pointer. Then float mean, variance. Again, standard deviation calculation, standard deviation, different methods are there. If you calculate variance, then square root of variance, you will get this standard deviation, right? Again, that is one method, or directly previous formula. We will use the previous formula, right? Standard deviation, then sum 0, sum 1, right? We will not calculate variance. Here we use variance. First we will go through this, then I will modify this program. Right? Standard deviation, then sum equal to 0, sum 1. These are the variables I require of type floating point. Then print, enter the number, value of n, means how many elements you want to store it in array. How many elements you want to store it in array? Then those elements you want to calculate the mean, sum, then standard deviation. That value enter here and n. Then start entering those values here. Now start entering those values, right? Single dimensional array. How to read single dimensional array values we have discussed in many programs, right? Enter real numbers. Enter real numbers, right? Printf, enter percentage d real numbers. And for I equal to 0, I less than n, I plus plus, start reading one by one. Start reading one by one. For example, you are at 2.0, 3.0, 4.0. Assume that you want 2.0 first, 3.0, 4.0, any real number, not only 0.0, point anything, right? Anywhere real number you are reading, right? Then p equal to x, you see our assigned pointer variable here. This is not a simple variable. You observe that there is a star here. There is a star. If you declare any variable preceding with star, then that will become a pointer variable of type this float, right? That's why this is a pointer variable. Since I assigned p equal to x, p equal to x means I assigned address of x to p. As I told, array by default array name is the address. By default array name is the address. That's why p equal to x means I am storing address of x into p, because p is the pointer variable. He stores, which has the capacity of storing address of other variable. That's why I am storing the address of x in p, right? Means p is not x value, p is address of x, right? Then for I equal to 0, I less than n, I plus plus, right? I equal to 0, I less than n, I plus plus. Then sum equal to, we are adding, all elements we will add. Then sum equal to sum plus star of p plus plus. Again, if I refer star of p plus, this is in direction operator, it goes to that address, takes the content from that address, right? For example, x of 0, what is there in x of 0? Assume that x of 0th index 2 is there. Then how to take through pointer variable? Star p, means it goes to x of 0th value, because x address you have stored in the p address. Means, for example, 100th memory location. 100th memory location we have 2. Then it goes to 100th memory location. Then it takes 2 there, right? Actually p is having 100. Assume that x address is 100. Assume that, now time being, assume that x address is 100. 100 is there in p actually. But if you are using star p is having 100. Right? It will not take 100. Actually p equal to 100. Actually, if you see, because x, assume that x is 100, then x you assign to 100. X is 100 is nothing but address of x. Right? Address of x is 100. Then that you are assigning to p, nothing but p is 100. Actually p is 100. If you use star p, it will not take 100. It will go to 100th memory location, it takes the content. At 100th memory location, if 2 is there, then it takes 2. That is indirection operation. It tells, indirect operation tells that don't take the value of p. Actually p is 100. Don't take that. Go to that address, because I have stored address of x in p. Go to that address, take the value. Right? That's why it takes 2, which is there in 100th address. Then 2 plus sum initially 0, then 2 plus, assuming if you have stored 2 in first index, then it will become 2. Then p is incremented now. Then p plus plus. Then pointer variable will be incremented depending on pointer type. Pointer's value will depend depending on pointer type. Since p is a pointer of float, right? If p is pointing at 100, then p plus plus is nothing but, because floating point data is 4 bytes, p will directly update to 4 bytes. That is 100, 1, 2, 3. Means if I do the p plus plus, then that is p plus plus. If you do the p plus plus, then it is it will point to 103th address, because next floating point number will be after 4 byte, because floating point number requires 4 bytes of memory to store. Definitely next number, if first number is at 100th address, then definitely next number is at 103. That's why P plus plus is nothing but it will not increment by 1, means if it is 100 it will not be 100 and 101, right? That is the data type. What data type? Pointer variable you declare, depending on that data type pointer variable it will increase. That's why if you do P plus plus in this case, first P is 100, then P plus plus means 100, 101, 102, 103. It will update 103, right? Then it goes to next, right? Because 103 you have next element, again it takes next element, like this it adds, like this it adds, right? Then sum becomes all elements sum. Here you have not used array, here you have not used array. In previous example you have used it like this, you would have used it like this, x of I, x of I. Instead of using this, you would have used it like this, right? X of I. It has also done same thing, but since he has used that, use the pointer variable. That's how we are using pointer variable here, right? We are not using array. It is also same thing, that pointer is also doing same operation, right? But since we are not using array, since we are using pointer, that's why we use pointer variable, right? Same, both are same, but this is a pointer variable. What that x of I was doing, same it is doing here, right? Then this you will get sum here. You will get sum means all elements. If there is a 2, 3, for assuming that I will take time being, I will take integer, since you can store floating pointers, so time being I will take integer. If you take 2, 3 means you have stored 2, 3, 4 in array, then 2 plus 3 plus 4. What is the sum? 2 plus 3 5, 5 plus 4 9. Sum is 9, right? Then how to calculate the mean? As I told, mean equal to sum by total number of elements. Mean equal to sum by total number of elements. Sum by float of n, because mean you have declared, again mean sum is not required. This is not required, I think. A float of n, because n you have taken integer, then sum is float. We will get float only. Again, I hope this is not necessary. Or implicit conversion, if you do also, nothing will happen. If you don't do also, nothing will happen, because mean normally you are getting floating point. Mean normally you are getting floating point. Anyway you have declared mean floating point. If you are declared integer, at that time you may require to convert this one. But if you take also it works. If you don't take float also it works, right? Sum, nothing but sum by n. Simply it is sum by n. Simply it is sum by n, right? Because sum is floating point, n is also floating point, you will get sum by n. Means mean, how to calculate mean? Mean, as I told, total number of elements addition divided by total number, right? That is sum. Now what we have to do? We have to calculate standard deviation. What to calculate standard deviation? Standard deviation formula you have seen here, right? Standard deviation formula is this, means entire formula. First what we will do? We will calculate this, that is addition of this, means xi minus mu I square plus then xi plus 1 minus mu whole square, then plus xi plus 2, like this. Means this formula will, this only this up to n, these values we will add, then afterwards we will divide this one, then afterwards we will take a square root, right? Step by step we will evaluate this one, right? Means first this formula, that is summation I equal to 1 to n xi minus mu bracket square, only we will evaluate for this first, right? We will evaluate for, calculate for this, right? That we are doing here, that we are doing. What we are doing, again I want array, because these xi's are nothing but array elements. Here xi is nothing but 0th index element, first index element, second index element, like that up to n number of elements, then minus mu, right? Mu is variance, mu is mean here, mu is the mean here. That's why then again we are adding. Here we have to add everything, we have to, because this is summation, this is symbol of summation, right? We have to add. That's why sum 1 equal to sum 1 plus power of, means power of means this, because this is power of, this is the power, square root. Instead of taking square root, I am taking power of, right? Power of 2, right? We are taking power of function. Then star p is array elements. As I told, x array element address we are stored in p, that is array element, means star p minus mean is mu, in that mean is mu, minus mean, then bracket 2, that is square root. This is bracket, this is 2, right? This we have to write power function. If I write power function, then this 2, right? Means what happens here? Sum, initially sum is 0, then first element minus mean bracket square, first element minus mean bracket square, right? Then you want next element minus mean bracket square, means again that element also you have to add to previous result, right? Then next you want next element minus mean bracket square. Then how to go to next element? Here p plus plus. Here as I told how we have done p plus plus. Then next previous sum, because this summation addition, this is a summation symbol, all values you have to add, right? That's why summation, then next element minus mean bracket square, right? Then p plus plus. Again next element minus mean bracket square, you add all. This is nothing but this we have evaluated. Only this part, that is summation I equal to 1 to I equal to n, I equal to 1 to I equal to n, xi minus mu bracket square. Only we have evaluated for. Now we got result of this. That result we will take, right? That result directly take, don't take variance, because we have asked not variance. Through variance also you calculate, yeah, you can calculate. That is the result is there. Then what you have to do? This result divide by n. This result divide by n, right? You divide it by n, right? That can be done. That result divide by n. How to do that one? Standard deviation. Shall I change this one? I will change this one. Yes, TD, standard deviation underscore D. Standard 1, I will take standard 1. I will take standard 1, one more variable. Standard 1 equal to what is that? Sum 1 by n. Sum 1 by n, because this, you see this one. This result divided by n. This result divided by n, right? That is what we are doing here. That I have taken std1 sum 1, that means sum 1 is here. That is the result of previous summation. Then divide by n. Then std1 I have to declare here. std1 I will declare. std1 I will declare, right? Then here, that is std1. Then now what we got from this equation? Now we got this entire value. Then we have to take the square root. Now we have to take the square root, right? Square root I will take. Anyway, this they have taken square. Instead of taking square root of variance, now we will take square root of std1, because already we have calculated std1. Means as per that explication I have done, right? std1. Then this is standard deviation. Right? Exactly this formula we have implemented. Means sum. If you get a sum, then from sum you can calculate a mean. Then from mean you can calculate this. That is every element minus mean bracket square. Add all those. Then you will get addition of those. Then after that you divide that one. To that you could take a square. Then you will get standard deviation. Same thing we have done here. First we have sum we have done, right? Then from sum we have calculated the mean. Right? We have calculated the mean here. Then from that mean, then inside summation from this equation. Inside summation, this we have evaluated. Only this part we have evaluated. That is what? This. That is this. Then after that we have to evaluate this. Means this divided by n. Because the entire result divided by n, that we have to do. That I have done here. Sum 1 divided by n. N is total number of elements. Then to that square root. Then entire result into square root. That we have done. Square root of SQRT built-in function. Then std1. Then if you use this one, then you will get standard deviation. Right? If you execute this program, then you will get output. Right? I will show the output. I will compile first. Then I will try. Right? Enter number of elements 3. Right? I will enter number of elements 3. That is 2, 3, then 4. Right? Then sum of all elements is 9. 3 plus 2, 5, 5 plus 4, 9. Then mean is total addition of sum divided by n. That is 9 by 3. 3, right? 9 by 3, 3. Then standard deviation. This This is standard deviation. Is it correct? You check once again in your calculator, right? This is a standard deviation, right? Like this, you can give any real numbers also you can give. I have given integer, now try with real numbers, because since our program is for real number of elements, right? Then I would give 4.3, then next 4.5, then next 0.23, then next 4.0, then next 5. Yes, correct? Okay, right? This is what program, then you will get output like this, right? This is the program of standard deviation. Go through this code, execute it in your home, right? This completes the program number 16, I hope. Program number 14, right? Thank you.